Hey guys, hello and welcome to this new video. This time a case solve for a Microsoft Excel World Championship DACH, so German speaking chapter case. Actually a case I wrote called Lake Constance or Bodensee, and it's actually about a lake because in the middle of the DACH region we have a lake bordering Germany, Switzerland and Austria, and it's Liechtenstein is also not far away, and it's really in the middle of the a little bit down, but basically in the middle of the DACH region, and it's a beautiful lake in front of the Alps. And I thought, why not do a case about this? And this is it, Bodensee or Lake Constance. Okay, also it's a two cases in one basically, because first you have the modeling part and then a second is a map part. But yeah, you will see that in a few seconds. Okay, inflow of the Alpenrhine in liters. It's an XLOOKUP for the date in here, returning cubic meters per second. And if you then multiply this with 60, first to get from cubic meters to liters, you have to multiply this one with 1000. Then to get to minutes with 60, to get to hours by 60 again, and then to get to days by to get to a day by 24. And then I recommend rounding to get rid of floating point errors, and then you have it. So that is basically the largest hurdle to like unit conversion, but yeah, you know, I like this. Here, that is basically the same, except this time it's in two-dimensional XLOOKUP. The row is given by the date. And the river is given by this, and then we again have this in cubic meters per second. Sorry, I did this case yesterday in German formulas. Times 1000 times 60 times 60 times 24, and we're done. Net water inflow. What is the net water flow of all inflows and outflows of at the corresponding date? So you not only have those inflows, you have also here inflow due to rain and outflows both through a river that is flowing out of the lake, and then also there is some evaporation, and also some water is taken to the lake there's a huge like pipe going to Stuttgart in that region, and that's also in here because they take quite some water from the lake. Net water flow, inflows, outflows, corresponding date. Okay, so basically I do the following. I use 8 stack and then XLOOKUP at this date for all inflows, then XLOOKUP at the state for the rain inflow, and then minus XLOOKUP for the state, so G120 at those states. And then we have here spill array, and if we sum everything together, we have the net flow for the given day in cubic meters per second. And then again, times 1000 times 60 times 60 times 24, and round recommended. Okay. Now level 4. Water level. This is the modeling part, so to say. what is the water level compared to the level at the beginning of the year. Every cell on the map is 1 kilometer. Assume the water level changes without any other influences and based on the lake area. That's an important hint. So what I first do, I copy this lake area. Then I clear everything out. And then Control H. Choose format from cell. Replace with 1. And you then know 552. That's the first hint, because that is the square kilometers of the lake, because every cell is 1 kilometer times 1 kilometer. All inflows and outflows are given in cubic meters per second. Give your answer in millimeters rounded to the nearest millimeter. And yeah, so basically you calculate the volume here and on a running basis. So what I did was using a scan function. Scan 0, and then your scan is date 2026 month and a sequence of 365 days. Lambda AB A plus, and now get rid of the rounding and of this here, and instead of this cell we swap in here B. I know you can also do this more efficient by simply making here a bi-row and then matching everything together would be also okay. But yeah, I did this method here, and then you have here the running total, and now you have to be careful. This is the running total now in cubic meters per second. Now times 60 times 60 times 24 is in cubic meters per day. Now we know how large the Bodensee is, the Lake Constance is. 552 square kilometers. And now you see here 5 divided by 552 divided by 1 million, and you get to meters, and this is our relative meter up and down. And then we do the following. I use here index of this, and our row number is this date minus the first day of the year plus 1. And now we have to multiply with 1000 to get the millimeter, and then round. And we have our answer. And as said, I think the more intelligent method would be bi-row of this plus this array here minus bi-row of this array, instead of X matching in there everything, but no worries. So now we are going to the map. So we have here a map, and I wanted to use here one of the new features, which is in-cell placement of pictures. And you see here, these are pictures of the flags. Here, Austria, Switzerland, and Germany. I've also, in the background, there's also a background color, so even if you don't have the flag, you can also work with it. So no issues on that. And we want to know what is in those, where those cities are. So which country is in the corresponding city. And what I would do in a normal way, in a non-lambda way, is flattening the map, enter addresses, and then searching for those addresses. and then basically give out the area around those cells with a split the address into row and column, and then add row and column together, and so on. But we can also do this with cell. So first, address lookup. One of my lambdas, I look up for the city in the map, and I get then the address. And then I use around, no, how is it called? Area based on return, area based on indirect cell reference. My range is 1, my sheet name is map. And I get here then the area around those cells. It's indirect based. And now I use a small trick, so to say. So in this case, I filter t if len of t is an error, because here those flag will return an error. Is error. Okay, hasn't worked. Why? This has worked, and then len is an error, and then is error true. Okay, interesting. Filter t is error len of t. Okay, now it has worked. And then intersection operator, xlookup, because you can also do an xlookup after a picture, actually. In here, returning the name of the country. And we're here done, and can go to level 6. So direct linear distance between those cities. Again, address lookup to get, this is basically I flat both the map and the addresses and make them an xlookup there. Nothing special. One of the most used lambdas, actually. And then the regular way would be split those addresses into row and column number, and then make a square root of the row number minus of the row numbers, the difference of both row numbers squared, plus the difference of both column numbers squared. And this is then your result. Or you have distance between cell references, cell reference 1, cell reference 2, distance put, and you also have this solved. And then don't forget to round not zero. Don't forget to round to the nearest digit. That was the issue. Interesting. Last level and bonus questions, of course. So actually, there are a few ferries between those cities, and we want to now know the ferry distance, so the distance when you only travel to the lake, but with a Pythagorean way. And the issue is, it is not always direct. So to go from Allensbach to Ludwigshafen or Bodman, you actually have to go here with a maze way, I would say. And I have a lambda for this I will show you, and then I will show you the manual way, which is not that hard actually, if you do it iterative. And yeah, how much do I want to talk about this again? Yeah, so basically it's a maze with direction related costs. And I use this here. I also have to swap out the cities against one. I know 552 kilometers, that is what I know. And then address lookup. I can also copy from above. And then I have maze cell distance map movement individual costs, map filled with ones, then the start address, now all arrows, and arrows I take arrow list diagonal second, and not the distance map. I need maze mover individual costs. Here it is. Because here I also can use a target address. So directions allowed, and now I stack in vstack 1 1 1 1, and for the squares, for the diagonals, it's square root of 2. And we have our solution. And then round. And we're good. So now, that was the lambda way. Now we do it the old school way, I would say. So first I copy this here on another map copy. Yes to all. Where am I? Stein am Rhein, and those. Okay, no, I actually need this as, anyways, I actually want at least the second one as formulas. Okay, good. Now get rid of the ones. And now we do the following. So you write an if formula. So if, and we are in cell in which the AV33, that's important. If here on the map with those names, if dot AV there, AV33 equals, here Stein am Rhein, I think it is. So our cell there we want to start, then it's 0. Otherwise, if on our 1,0 map, and here again AV33 equals 1, or is something, I think equals 1 is not necessary, but for clarification I use this, then our value in this cell here is the minimum of the surrounding cells, and I only take here the non-diagonal cells first, plus 1. No. I want to, as I know, I want to click here. So plus 1. So no zoom. Otherwise, it's something large. So here this is 1 because the other cells are not filled. And here, if it's diagonal, then it's diagonal plus square root of 2. And we do this for all diagonal cells. And now we take our formula and fill it over the C. And yes, I know it's iterative now. And therefore we go to options formulas, iterative calculation, and we have here an error. No, is this an error here? Yeah. Why is this ref error? BB. There's something odd. Okay. Control Z. AV. Everything should be fine. Okay. False 10,000. Yeah. Should be fine. Okay. Again, we try to copy it. What was the issue here? Why is this BB? Huh? Why is this referring to complete different cell? It is, you saw it. I know what the issue is. Julian, you should make this here. This cell reference here is an absolute reference. Of course. Now fill in formulas. And we are starting. What we also should do is fill this cell here below with our large number. And also those cells here with our large number. And I should have dragged this further, this formula here, because otherwise it is taking here those cells from here, and empty cells are also treated as 0. But as of now, it should be fine. Yeah, now it's fine. And then we can use here we have the second row and column, the second address, and we take there the row number from the cell reference and the column number from the cell reference, and use an index. Of the whole area, row and column, and also have the same value as before. Now we create there quickly a data table on the sheet. Around this here, and this is then now I have to watch out, equals x lookup 121 equals x lookup for this in here, returning this here, and I watched out here that I'm not having here an error, and this is then H. Ludwigshafen Lindau 60, yes. Now data table this, data, what if analysis, data table, column input cell here, calculation shortly, and we get to the same values with our iterative approach. Now, bonus question, which river is providing the largest inflow? So basically by call of this and sum, and you then can quickly see here, oh, the maximum is here, and it is the Alpenrhein. What is the total inflow? Only use rivers and leaders on the day with the highest inflow. So basically by row sum times 60 times 60 times 24 times 1000, and we want to have the maximum based on level 4 rules. On what day is the water level the lowest? And now it's good that we have here a scan function, because we can then simply use here our scan and then say, okay, we do an XLOOKUP for min of S in S, returning date 2026, 1 sequence 365, and we get to our date value here. Now let's copy this in our bonus cell. Done. How many cities on the map are in Switzerland? So here I recommend to do this manual. So 1, 2, 3, 4, 5, 6, 7, 8. Or what you could also do is flat the map, take out all cities, and then use the approach from here that you map in all the cities and then try to figure out from what country those cities are. But I take the 8 I took manual. Sometimes the manual approach is the fastest, but not always ever proven. What is the largest distance between two cities? So now flat the map. This does take too long for me. Filter for blank values, yes. The issue is on the iterative sheet. Okay. I get an error. Here we go. And then I take here len and then filter this if not is error of len. So to get rid of the flags, and you then get here a few zeros and our cities, and then I filter again the whole table if this here is of len of this. Let's take len of this is larger than 2, and we then simply get only our cities. And then I do the following: 2-dimension to row of the addresses here, and then distance between cell references. This is cell reference 1, this is cell reference 2, Pythagorean distance, and simply track this aside, and we have our solution. This is the maximum. I think we have to round it. Yes. And we have solved the case. So under 30 minutes, that's good. I hope you like the case. I thought, what is something that all, at least all German-speaking countries from the DACH region can relate to, and this is the Lake Constance. So yeah, I hope you like this case. Might be a little bit too much math again after underground mining, but yeah, hope you liked it. Anyways, write down in the comments anyway anything, and yeah, hope to see you next time. Bye.